Hello friends, and welcome to this part 2 of the series where we are talking about the physical construct of data lake. Now in this part we are going to talk about the ingestion mechanism depending on the different types of data sources. Let's go to the second swim lane which talks about the ingestion. So the first one in this category is the AWS Glue. So what is Glue? It's a serverless ETL tool. Gone are the days when you purchase a licensed software, acquire a hardware, install all this software on that hardware and then run it. Even if you are not using it, you are paying for it. You are paying for the hardware, you are paying for the licenses and everything. Don't go with those kind of mechanism. Now the whole time is about serverless service. The additional thing is that it's a pay as you give. If you create a ETL job and you run this job for suppose 1 hour, you are only going to pay for 1 hour, nothing more, nothing less. It supports Python and it supports Scala. These are the two programming language that it supports. If you are writing in the Python code, so internally it generates the PySpark code. It provides you the complete studio setup where you can do the complete GUI based ETL logic implementation, whatever transformation you want, whatever aggregation you want, all those kind of things. If you want it at the time of the loading, you can do it using the Glue. Second thing is it has got the data brief where you can manage the complete data stewardship, data cleansing, data management, everything that you can do out of this after this tool. And it's again a GUI based tool, very easy to use. So Glue is one of the most important service from a data analytics perspective, and as well as if you are preparing for the exam, from the exam perspective also, this is a very important service to be there. So this is how Glue does is that it fetches the data from here and it sends that data into the raw bucket of the data lake. One other service is there which I have not mentioned, but this is another very important service, which is DMS, Database Migration Service. If you have a continuous replication of data from source into the data lake, which we also call as CDC, which is change data capture. If that is the scenario is there, that as soon as any update is happening on the source side, the same changes needs to be reflected into the data lake side or a target side. In those scenarios, generally I would prefer to go with the DMS, but DMS is not a serverless. It's a managed service but not a serverless. You have to procure a EC2 virtual machine, and on top of that it is getting deployed there. Next come the streaming part, the streaming data. For the streaming data, we have the Kinesis Data Firehose. So Kinesis Data Firehose, this is actually a streaming service which takes the data from the source. So suppose this is my KDF. KDF takes the data from the source and sends the data to the target, which is my data lake. Now how does it take it from the source? On the source side, we have the SDKs which are available in different languages, different scripting languages also, as well as we have the APIs. You can use any one of this mechanism. If you can use even JavaScript kind of thing on your code, as soon as there is a click event using this SDK, you put the data into the KDF stream. So KDF, you can create different channels within KDF, and within this you can send your data directly there. So on the source side, you have to use either of the SDK or the API to send your data to the Kinesis Data Firehose. As soon as KDF gets the data, you can then either keep that data for some time or you can send it directly to the data lake. That is also the option there. Generally, we prefer not to send it directly to the data lake, because on the data lake side, which is the S3 service, there is a charge for every put request. So better you buffer it here, and then as a batch you send that data to the data lake. Hope you have understood what is Kinesis Data Firehose. Now come to the app flow. As I was explaining about the SaaS part, that when it comes to the SaaS based kind of application or any such application where you do not have direct access to the database, in those scenarios you go with the API based kind of mechanism where you fetch the data through the well-defined APIs. So in SAP also, either if the API is already available, you can do it. If the API is not available, you have to request to the SAP functional team to develop those API and deploy it. They have multiple mechanism of doing it. They can do it on their PIPO. So SAP has got something called as the PIPO. It's a module where they develop the APIs and then they deploy it to be consumed by the different interfacing application. Or they also have a mechanism called as the OData. So using OData also, they can expose those data which are required by you, and you can fetch it as an API from there. So both the mechanisms are available. Salesforce, as I have said, that it's a pure SaaS based application. So anyway, there is no other mechanism other than calling it through the API, and that you can do it using the app flow. So app flow will help you for both the event based as well as the scheduled data ingestion mechanism which is there. Finally, the industrial part, which is the IoT site-wise and the IoT core. IoT core is anyway required wherever there is a device. IoT core would be required, but IoT core is more required in terms of the smart devices. So if you have the smart devices, you are sending it to the queues. So IoT core exposes the queues. So there are different queues which are exposed, and you can send your data from the smart devices into those queues. And the protocol, as I said earlier, which is used, it could be MQTT also, that you can, or over the WebSocket also you can send those data. If it's a industrial setup, if your customer has a manufacturing background, now in the world of manufacturing there is something called as the tag hierarchy. So tag hierarchy. Now what is tag hierarchy? Here it is like you have plant. Within plant you have different divisions. Within divisions you have different production line. Within different production line you have different machines. So you can see that this looks like a hierarchy. So this kind of hierarchical data, it is not generally possible with a normal database, and that is why IoT site-wise is there, which is a time series data storage service, where it maintains the industrial hierarchy which you have defined in your system. And this is very much required when you are creating different kind of dashboards out of it. So with this, I'm going to end the part 2 of this session, where we spoke about the different ingestion mechanism and how AWS services can be used for this different kind of ingestion mechanism. In the next part, I'm going to talk about the LakeHouse architecture, how AWS services can be used to build the different components of the LakeHouse architecture. So I hope this session has been useful to you. Stay tuned for our next session on the LakeHouse architecture. See you then. Bye-bye.